here working on our MIDI player, okay, and we're working on our code to allow it to play an arpeggio, okay. And if you remember what an arpeggio was, looks like this. There you go. Without the chord, it goes like ba da 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 da, and that's what we're trying to do. And thanks to Super Manjo here for showing us. That's great. And what we're going to do is we're going to look at the notes over here. Okay. Basically, notes translate in MIDI to these MIDI commands, like we've seen before. Okay. This is a C. I think it's like C5. And the notes for an arpeggio on starting on C5 with a root of C like that would be, you play C, you play E in the 5th octave, you play G in the 5th octave, you go up to the 6th octave and play C here, come back down, come back down, come back down. Okay, so it looks just like what's going on here. Okay, like that. And but what you can do then is you can take the MIDI commands and you can send them through our note player like this. Okay, so C5 translates to 60. Okay, the E5 translates to 64. The G is 67. The higher C is 72, and then back down to G and E and C. Okay. Now, if we want to make it variable, because we have a potentiometer running on the root, okay, so that's the thing, we're able to actually change our root note. So what we actually really care about is, and what's cool about music is that for any arpeggio, it's like the differences in tones that make the arpeggio. Okay, so this is a major arpeggio, and the difference between the first note and the second note is 4, and the difference between the first note and the third tone is 7. And the difference between you know, a note and its octave is 12. Okay, and anything like that is great. Okay, and then it goes back down to 7 and 4 and 0. Okay, the root is not different from the root. So if you shifted the root and started at 60, okay, you know, let's see, if we shifted the root to 60, 61, then the tones would be equal to, it would be 61, like we thought, okay, and then the next one would be 65, right, because it's just 4 difference, okay, and then the next one would be 68, okay, 7 difference, right, okay, and then the next one would be 73, okay, and then back down to 68 and 65, and so you can do this with anything, okay. I mean, any note, starting at any note. So if we did here, it would be 60, bomb, and then it would be 65, bomb, bomb, you know, bomb, 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 and then keep going, okay? And so this works out with, it's just musically it works out. So that's sort of a good thing. Okay, so let's go to Arduino then and try to get this going, okay? In Arduino, what we have is we have a good setup right now where we look at a button, we look at a potentiometer, and we kind of start out with this root, which is C4 in MIDI, okay? And then what we do is we run a loop which gets the pot value, and whatever the pot value is, we map this to like an 84 different notes, and we play our arpeggio, but our arpeggio is kind of lame right now because it only plays one note. It's just like one note. So what we want to do is expand on that. And what we really care about right now is this bit here where you care about the deltas. So what I'm going to do is, based on my root, I'm going to make something that will always play these deltas. And the way to do that is to make an array or a list. Okay. And I'm going to call this relative tones, or relative tone, something like that. Okay, that's you make the square braces to make a list, and then you put in your list values. And what we care about are these. Okay, for major arpeggio, and you can change this for like a minor one. You can change it for like a 7th one, and you know we're trying to play the AC/DC thing. But this all will work. Okay, there you go, and We can also get a value for the number of tones that we care about here. So right now there's 1, 2, 3, 4, 5, 6, 7, and I'm going to make a value for that. Make tone list length. Okay, and that equals 7. And there's actually a command for this in Arduino language. I think you go like this. You say relative tone dot length. It might be, yeah, I think that's right. And it just gives you a number. So we want this to be 7. I'm going to check on that real quick. Well, checking on that, let's just use the number 7 for right now. It seems like they use like members of, but it seems like there's sort of a length concept that isn't really quite. It's in other languages like C++ and Java and things like that, but here it might not be so available. I know that when we run this, it runs faster for sure when you do something like this, and then we have a fixed array, so we're not trying to like do anything here. So so let's just use a number for right now, and that seems pretty good. Okay. Then the question is, can you write a loop? What we need to do is run through this thing for every note in our arpeggio. Okay. And what we want to do is we just want to write a for loop for that. Okay. And the question is, can you remember what it is to write a for loop? For loop has different values that start it. A for loop is used for fixed iterations, and we need to do 7. That's good. So we're going to go like this and say for, okay, an int starting at 0, and a list always starts at 0. So in this list, this is the 0th item in the list. This is the first one. This is the second one. This is the third one. This is the fourth one. This is the fifth one. This is the sixth one. So even though this is 7 things long, the last element's always one less than the kind of the length of it. So, and that's sort of a good thing. So we're gonna go, we're gonna start at 0 and go while, we have to set up some integer first. We have to set up like an n for note, and then it's gonna say while n is less than our variable here for tone list length. This guy here. And what we're going to do is go up and up in tone, okay? So we're going to go plus plus n, okay? Like that, okay? And then what we're going to do is the root here is going to be the root basically plus the tone list of n. Okay, and then we're going to turn this up. So whatever root we are, we can do it. We can do whatever note we're on. So what happens is we're going to do this, this, and we have to finish up our loop. Okay, and voila, there it is. We should have done it. So your job is to get this done, see if it runs, and let's compile it. Make sure that this guy runs compiling it. And oh, I got a problem with tone list. I'm gonna call it. Oh, it's called relative tone. There you go. Okay, so let's compile it again. Make sure we get through there. Okay, and that's it. And you want to try it with your your MIDI setup. Okay, which means that you need to go to you get the Arduino, you download it to the Arduino. Okay, you go to applications. We open up our native instruments. Where's that guy? There it is. Okay, not that. Contact. Okay, and we open up um, the hairless MIDI serial translator. There it is. Okay, and then you connect everybody up and you play it. Okay, and you gotta get your MIDI here. You gotta get your Arduino on here too. So what I want to see is I want to see like a minute video of us playing them and making it work. And we'll talk to you later.